Hi, it's Sukrit from STEM Coder, and in today's video we're going to take a look at a practical application of the derivative King Kong dropping a piano off the Empire State Building. Let's get started. This is going to be exciting. Over here I have a pretty bad drawing of the Empire State Building. It's got no windows, but whatever. It's an Empire State Building, and this ledge over here, this first ledge, is 300 meters off the ground. It's 300 meters off the street below. King Kong is perched atop this ledge and he wants to drop this piano onto a car parked on the street down below. What car is it? Let's just say it's a Lamborghini. So King Kong wants to drop a piano onto the Lamborghini. So over here I've got this function over here, y of t. And what is y of t? Well, it's the function which defines the y position of the piano t seconds after King Kong first lets go of it. So initially the y position of the piano is going to be at 300, and the street is at y position 0, so 0 meters, 300 meters. And this formula over here is basically used to calculate what the position of the piano will be, the y position, t seconds after King Kong first lets go. So 0 seconds after King Kong first lets go, the piano is obviously going to be at 300 meters. But hey, this looks like it's negative. It's not. This is positive 300 meters. This is 0 meters. But 5 seconds after King Kong first lets go of it, what's the position of the piano? Well, we just need to take y of 5, it's 300 minus 1/2 times 9.8 times 5. And I'll let you calculate this yourself, but whatever it is, this is going to be equal to the position of the piano 5 seconds after King Kong first lets go of it. However, when you drop a piano off a building, it's going to be going fast pretty soon, really fast for that matter, but how fast exactly will it be traveling? Well, I want to find out how fast the piano is traveling 5 seconds after King Kong first releases it. So what is velocity? We want to find the velocity of the piano, right? And velocity is expressed in meters per second, miles per hour, or kilometers per hour. So it's just some unit of measurement of distance or position divided by some unit of measurement of time. So like in this case, we're going to use meters per second. So what is another definition of velocity? Well, let's say my piano has velocity v. It's traveling at v meters per second. So what does this mean? That means that every second my piano is traveling v meters. So my piano's position is changing by v meters every second. At least that's how fast my piano is going to be traveling when its velocity is v. So meters per second, my position is changing by v meters every second. Does that sound like anything familiar? If it does, you are correct, because velocity is simply the derivative of position with respect to time. It's the rate of change of position with respect to time. And so in order to find how fast the piano is traveling after 5 seconds, we just have to take the derivative of position with respect to time. So it's going to just be y prime of t. Or we can also write it as d over dt of y of t. That's y prime of t. And this is going to be equal to negative 9.8 t. I just had to use the standard power rule over here. Okay, so negative 9.8 t. This is the formula we need to use to calculate the velocity of the piano t seconds after it's dropped. So why is there a negative sign over here? Well, this piano is heading downwards, right? And its position is actually decreasing. So initially its position is 300, and then its position will be decreasing all the way it gets down to 0. So that's why my velocity is negative, because remember, velocity is just how much my position changes by with respect to time. And you can clearly see that my position actually, at least the value of my position, it actually decreases. So that's why we have a negative velocity in this case. So after 5 seconds, how fast is my piano traveling? Well, y prime of 5 is just equal to negative 9.8 times 5. And I'll let you calculate the result, but this is how fast the piano is traveling after 5 seconds. And by the way, if you do this calculation, it works out to a pretty high number. If someone does drop a piano off the Empire State Building, I highly recommend you get out of the way fast. So we want to find one more thing. We all know that when you drop something, it accelerates. So like 1 second after you drop it, it's not traveling that fast, but like 10 seconds after you drop it, it's traveling quite fast. Well, how do we find acceleration? Acceleration can be measured as the rate of change of velocity with respect to time. So how much is the velocity of the object changing with respect to time? And that's just going to be the derivative of velocity with respect to time. So ultimately we go from y prime of t to y double prime of t. See, we're actually using second derivatives. That's just going to be equal to negative 9.8. once again, we have this negative sign in the front because my velocity is technically becoming more negative. Initially, my velocity is 0 up here, then it goes to -10, then -20, then -30. And once again, my velocity is negative because my position is technically decreasing. It's going from 300 to 200 to 100 to 0. So that's why we're using negative numbers in this case, because my position is technically decreasing. So what this means is that this is 9.8 meters per second squared. So 9.8 meters per second. That means my velocity is going to be changing by negative 9.8 meters per second every single second. It's pretty heavy accelerations. That means after 5 seconds, the velocity is actually going to be equal to negative 9.8 times 5. Why is that? Because if my acceleration is negative 9.8 meters per second squared, that means every second my velocity is changing by negative 9.8. And by the way, this is actually pretty insane. This is actually all the more reason if someone does drop a piano off the building, get out of there super fast. And if you have any cars parked, just ditch the car. Your life is more important. So anyways, I hope you enjoyed this fun little demo. Derivatives certainly have a practical use. And just remember that position, velocity, acceleration, that's how it works. Velocity is the derivative of position with respect to time, and acceleration is the derivative of velocity with respect to time.